Over to you, Chan.
Perfect. Well, again, thank you for guys having me. You heard, my name is Chad Gruka. I am a senior software developer with Trilogy. Amazing company. Consultancy allows us to get us into lots of great and interesting things. And one of the more recent issues and things that we help solve for one of our clients is going to be durable functions and how they need to be versioned. Um, Today, we're going to step through a number of things. Let's go ahead and get this going. Because durable functions is more of an extension of Azure Functions, I'm going to do a little bit of a kind of a rundown, if you will, of what functions are at their base plate, and then expand upon those as to where durable functions come in. Because some may not have used Azure Functions, and I want to give you an opportunity to understand the baseline for where we're at and why we need durable functions. And then we'll expand further into that as to why we need to version them, right? So versioning is further extension of the durable functions. We'll talk briefly about durable functions and the different patterns and why it matters, the gotchas that you might come across, as well as some tooling that'll help you, troubleshoot and moderate your durable functions as you're under development. And then we'll go into a brief demo. I'm going to kind of give you a quick tour of a functioning durable function app, and then we're going to go over that in great detail to further understand it. And then we'll cover versioning options, slot deployment setup, which is one of our key versioning options. And then we're going to go into how we would deploy this scenario. I'm not going to go into too much of the CI/CD bit, but you can probably imagine that as we get through it. So what are Azure functions? So for anyone familiar with AWS, those are similar to Lambdas. Basically, it's the smallest piece of code that you can run, throw up on a server, and have it execute. It can do any number of things. Quite often, I find myself using HTTP triggers, timing triggers, queue triggers, blob triggers. Most recently, getting involved with event grid triggers. All kinds of different triggers that basically raise an event and tell your Azure function to go off and run a block of code that you've written. So this is really, again, just meant to be small, finite amount of code that we can run. The nice part about this is it doesn't have to be C#. I'm a C# developer. I have been for 20 years now. I'm kind of ashamed to say, but that's good time. You can run it in Java, JavaScript, Python, and a few other languages as well. So whatever your flavor happens to be, Azure is going to support that. One of the interesting things about Azure Functions is that they are short-lived by nature. They will only last by default for 5 minutes and can be configured to run up to 10 if needed. And that is in what they call the consumption model, right? If you want to, you can give Azure your credit card and they'll bill you for the microtransactions for every time, so many executions and minutes and processing and memory that you use. So that way you're not hosting a whole server for something that might run once a day. A nice job might be something that goes off and pulls down weather reports and ingests it, massage it, and then maybe dumps it into your API stack, so that it's fine-grained in doing so. There are ways to extend that. You can pay for a full-on server, and at that point you are not capped. So if you find yourself in a position where you want to remove that limit, you can certainly do so. They're stateless, right? So the moment these things are raised up and triggered by any one of those possible events, and there's more than these, I just quickly grabbed a screenshot of the few that could fit on a slide deck nicely. So when they run, they have no idea what happened to something prior. They are stateless. They no state. They will have to go out and get data from an API or something to kind of refresh itself if that was the case. So where are we? We need to maybe polish this up a bit, maybe find a little, solve a few issues that people might have with this. And so what we have are durable functions. Durable functions, they're an extension, right? So, I can take one function and I can chain them together in a number of different patterns to formulate a solution. And it helps me break through some of the limitations that functions by themselves wouldn't solve. One being state. With durable functions, we get the benefit of state management. I believe that's managed through a CQRS type pattern that Microsoft has developed for us. So we get the benefit of it without too much effort. And, this is going to enable those longer workflows, right? So I might have a workflow, for example, that I might say create a expense report and I'm waiting for my manager to approve it. It could be minutes, days, hours, weeks, hopefully not that long because I want to get reimbursed. But there are ways to run a durable function for a longer period of time and allow it to live. And then once my manager approves it, an event grid push could trigger it to say, hey, he approved or rejected that expense report. We get, like I said, state management. There's things such as checkpointing and retries. So should something maybe go awry, maybe you are reaching out to that weather endpoint and they happen to be down, you would have the ability to resubmit that job if you want it, if you didn't have that polling on a timer basis, but maybe, it was triggered off something else. You could have it retry for you through any number of avenues. Like I said, there's also multiple patterns that are prescribed for that. What we have with durable functions is you got the chaining function. I run one function, it calls another function, just to chain on. Like I mentioned, the expense report, you got the human interaction. You got the fan in, fan out aggregate for the stateful entities. Typically with that, you're looking at something probably more in line with like an IoT type setup, ingesting large quantities of data and having to amass that in some logical order. And an aggregate pattern will manage that for you. One thing about the fan out, fan in model, I used that myself once for a client that needed to digest, if you could imagine, 500 megabytes worth of JSON payload. And I managed to get it to process that all through a function, so it didn't have to actually get processed on a server. It got processed in durable function, and he only needed to have to pay for that duration of time that those functions were actuating. It's pretty neat pattern. I like that one a lot. And also async, also pretty handy. There's more than this, but these are the top 5. So when you're dealing with Azure functions, a lot of times you're going to find yourself kind of wondering where things are at. Azure's functions by nature, they run on top of Azure storage. So that's where they're managing their state. So if you're wanting to know where a given instance is in its process, maybe an instance failed and you want to know why, we have the Azure Storage Explorer. I'll show you where that's at. It's a very common tool that we use just for looking at storage queues, tables inside of Azure. And then you also have the Durable Functions Monitor, which is a VS Code plugin that allows us to interrogate the individual instances of your durable functions. Handy tools. Think you need to know that these exist if you don't already. All right, I'm gonna switch over and we're gonna show you a sample application as soon as I can get that to go away. Perfect. So like I mentioned before, I code in C#. I use Visual Studio and VS Code. So let me know if I need to, I'll zoom in on this a little bit so hopefully everyone can read that clearly. Let's start with the basic concepts of durable functions. With durable functions, you get what's known as an orchestrator, and then you also have activities. So Durable functions are composed of those two main elements, and the entry point into any durable function is through an orchestrator. So again, with this, what I'm showing you here is an expense report orchestrator, the main decision making ability. It provides three main functions. One is the ability to provide some type of auto decisioning should a manager not provide input in a timely fashion. There's the ability to get a decision back so it can be moved forward. Highly theoretical. This is not a normal, but it helps explain the need for versioning. We have the manual review step. So this would be as if my manager decided to approve it or reject it. It would come inbound. What we have here is the timer. So in this case, we're giving them 30 seconds. I don't want you to wait 30 days, which would be a normal time frame for something like this to time out. But because durable functions can run to infinity and never end, we want to provide a backstop for it to basically end and make some type of decision. Those that are familiar with the async await tasks, we're taking the manual decision as well as the timeout decision. We're grouping those together. And what we're doing with these is we're waiting until whatever one comes first. And once we have a winner, we then decide which one, if it is coming from a manager, we'll get it whether or not it was approved. And then we'll move on from there. If it wasn't approved, then we call back and let the instance know that it wasn't, or vice versa. All right, approved, rejected. So as you'll see here, we've got call activity, call activity, call activity. Three main activities plus one external event. These are the prime entry points, and I'm calling these out specifically because this is where you can get into trouble with Azure function with durable functions. If we make any changes to the contract signatures for these items, so for example, this one has a contract signature of accepting an auto decision payload as an object. If that were to change, or maybe the return value were to change, what ends up happening is that anything that is in flight, right? I get 30 seconds isn't long running, but for the sake of this demo, we're using 30 seconds. Make any change to this, anything that's in flight would ultimately fail. And that's because the state is no longer aware of how to cast from, say, if this was originally returned as a string and now it's a bool, it's not going to know how to translate that back. And so it's just going to fail. And so that's why we're here today to talk about versioning. So this is just the mainline course. Again, we're going to get an auto decision in the event that a manager doesn't come back. We're going to check for 30 seconds for a manager's review. We're going to time out after 30 seconds in the event that we don't get it. And then we're going to record that approval. Now, the storage on this is all being done in the Azure function. We're actually using entities. Durable entities is another extension of Azure functions. We're not here to necessarily talk about those, but for those that are interested, we might have time at the end to dive deeper into that. But just know that we are storing state of any of our submissions using durable entities. Okay, so let's go ahead and fire this up. I just want to show you a working application first, understand the experience, some of the tools that we're going to use to interrogate this and know where things are in flight. So you see my function spun up. It's currently loading up all of our tables and necessary elements for the durable function to live. And then we've got a bunch of endpoints. So this isn't pretty. I decided that we should probably show you something a little bit easier. For those that are familiar with Swagger, this is very familiar. Okay. Few endpoints, nothing major. We've got one here for submitting our expense report. We've got one for a manager to submit a review. We've got two additional endpoints here. Just for the sake of verbosity, they probably could have been one, but these will be the callback methods or endpoints for our approval process. So let's go ahead and create a submission for an expense report. Going to Omaha because I'm in Colorado right now. Probably about $450. Okay. We see that workflow has been created, and I'm going to show you the endpoint just to show you what we've got for data on that guy. You'll see here that that's been filed, the reason, the amount. No one's approved it, no one's rejected it, but we know it's on an instance. So what I'd like to do is show you VS Code, and VS Code is now going to show for us that that instance is over here running. And in fact, well, this would be an instance of it. And let's see, maybe it's right here running CEF. Okay. This is waiting and waiting and waiting. So in 30 seconds time, this is going to auto approve. But the nice feature about this plugin, so this is that plugin I mentioned, that is the Durable Function Explorer or Durable Function Monitor. I don't remember exactly what its name was. So this gives us a lot of detail and telemetry data off of it. You can see when it started and individual tasks and understand the underlying foundation of durable functions. We've got table storage, we've got queues, we've got a number of things at play. So when we're trying to debug these things, it's important to know when these things fired off and whether or not they've completed successfully. We can see now that this task is actually completed. You can see the input that we gave it. This is not the input I gave the API. This is the input that I gave the durable function. Okay, you get sequence diagrams. This stuff is super helpful. Whoever put this together, God bless them, because this has been super helpful in me debugging these things, because otherwise all you would have is table data to sift through, and that's no better than a log file. So this is much prettier and super helpful, like I said. Let's go ahead and close that. So we can see now that that set is successfully completed. I didn't approve anything. I assume you guys don't have access to approve anything. So that means the 30-second timer kicked off. So we can go and interrogate that. And now we can see that that got approved. So it fell in the timer, right? So why did it get approved? And we can see that there is decisioning logic that we added up here that basically said, if it's less than $500, right? The amount is less than $500, auto approve this. Okay, so we didn't need necessarily a manager to approve it, but we made a decision anyways. So let's go forward and show you what happens with something that's long running and potentially dangerous if we have some, think scale here, right? It'd be one thing if these were short-lived processes running, 4 or 5 seconds, maybe 5 minutes a piece, not a big deal. But when you got something like an expense report, this thing's going to potentially be living out there for 30 days waiting for an approval. So these things have a long life, and we need to address that. And so what I'm going to do is we're going to fire off another, get the right screen. This time we'll do 550. We'll execute that. I'm going to wait for this job. Right now it's pending. It's not really started. Now it's started. I'm going to stop it. Okay. These are stateful. Okay. So a normal Azure function, you just cut bait and bailed out. All that data that I just sent it would be wiped out. So let's go ahead and make a quick code change. Go here. I'm introducing a new auto decisioning process for the sake of brevity and for example purposes. I'm no longer returning just a bool. I'm now going to return a strongly typed object with a similar payload and a message, so that we can response that out if we wanted to. So we're now going to say that signature has changed. Obviously this has changed as well. So we're going to do is approved. So that's it. Super simple code change. Most people wouldn't sweat this, but again, one of the gotchas with durable functions is I just made a signature change. What happens? Fire this up. Again, this thing's out here still thinking it's running, right? Again, stateful. So as soon as this thing kicks up, all right. Give it a second to tick through this. Loading up the host. Got our endpoints and our durable functions. And because it's only 30 seconds, there we go. We got a failure. Not good. So we go over here, refresh. This job failed. Enterprise environment, this would cause major issues. Potentially hundreds of expense reports just got canned because of a simple, fairly one line item change on that signature to that activity, and we're dead in the water. So what's next? I'm gonna hop over here and go to a slideshow. So that was that demo. So as you saw, some of the gotchas as far as for durable function, changing signatures is a bad idea. There's a number of these, right? So you got checkpoints, awaits, or yields, right? So that's what we experienced, right? There was a checkpoint that took place on an await. It held on to the data originally as to what had originally come back, which was a bool. When we changed that signature, it was expecting a bool back because it stored that result in memory. And when it loaded it back up, it said, you know what? I don't know how to convert this to a bool. I'm done. Again, lifespan is infinite. We've got helper classes for goods and date time. It's very important to know that you can't call datetime.now. That's not going to work for you. And the same thing with goods. They're just not a great idea to use those. So there's helper methods off the context to get those values if you need to timestamp anything or new up any GUID values. So requires deterministic APIs, very similar to what we were talking about with the method signatures. Avoid static variables and constants is what you should be using instead, and that is just for orchestrators, right? So deterministic APIs and the static variables, these are concerns at the orchestrator level. These are fine to use in the activity level. So orchestrators call activities, it's fine to use those there. Any calls that you're using to APIs must put those behind an individual activity, even if it's super simple. And that's just because once it calls it once through an activity, it's going to cache that payload. So if you can imagine, if I had created this durable function to call back out and grab the invoice data every time, right? And then some state on that invoice could change, or on that expense report could have changed in that time and could have changed the dynamics of what I was doing. So we want to work with a single set of payload, and so we want to make sure that we're doing it behind activities, because the result of that ultimately gets written into the tables that durable functions use. One other gotcha, this was something that I learned just a few weeks ago. Limit your function names to 32 characters. With durable functions, there's certain triggers that get written that if you go beyond 32 characters, it might look like it's working, but certain triggers will ultimately not, and it may cause a lot of undetectable errors or issues with your durable function. So this was a big one that I learned and didn't find until seriously one line of code in the Azure documentation. Limit to 32 characters. So, and then obviously versioning. So how do we make that change? How do we ship something to production, allow process to still continue without us having to stop those already running durable functions? So we need to know when we're going to version them, right? We only need to worry about that with long running orchestrators. as well as for breaking changes, whether you're changing the activity signatures or the orchestrator logic. That's another breaking change, right? This is when you need to consider durable functions. Now, it's not to say that versioning is a requirement. It's really going to be at that point more of a business decision, is that whether or not you need the ability to version these off, right? So one opportunity that we have with durable functions is that we can actually restart them. We can turn around and just tell them, hey, I know you're working on something, but hey, go back to the beginning and try again. And that is a very common pathway for doing it. But what if you've sent paperwork off to an outside vendor and you're waiting for that information to come back? You don't want to send that paperwork, digital paperwork. You don't want to send that information off to them multiple times or every time you have to version your durable function. And if you got CI/CD in place, that can become a nightmare. So there may be opportunities that you just do restarts on all of your currently running instances, but in some cases, when you're leaning on third parties outside your organization, you'll have to consider versioning. So mitigation options, do nothing, just let it fail. You may have a durable function, like I said earlier, might be reaching out to a weather endpoint, and you really don't care if it comes back with the data or not in a given time period. It will just pick back up at a later date, and you're fine with it. Probably not the best experience, but still plausible. You can stop all the in-flight orchestration instances, kind of like what I just mentioned about for restarting them. You stop them all, you do the deployment, hit the restart button, and off they all go. Or we run side-by-side deployments. With side-by-side deployments, we have a number of options. We have the ability to, just wholesale create a new Azure app. Might be difficult because now you've got new sets of APIs, endpoints within to reach that Azure durable function. There's a number of issues. Another option is to create and use a new storage account, or use the existing storage account with a task hub if you're going to go that route. The other option is, if you don't want to get away from the URL changing that happens as you create new function app, is that you use the deployment slots. We're actually going to walk through that one today. So I'm going to walk through, these are probably more for my notes and probably for your reference should you come back and watch this, but there's a number of key areas and gotchas to having to pay attention to, and I'm going to show you those here in just a minute. But we're going to have to touch the host.json file. There's a specific value in there to address the task hub. When we're dealing with slots, for those familiar with slots, each durable function instance you get will allow you up to, I think, 20 slots. So we can have the similar running code in 20 different slots, all doing work simultaneously. And so what we need is to isolate that. And the way we isolate that work is we use different task hubs, and that is a foundational component to durable functions. We've got a few configuration values that we would have to address. And then one of the key recommendations is you want to do work through queues, or at least your main entry point into your durable functions. You want to transition from maybe being an HTTP request to now being done through, I put a message onto a queue. And the reason why we do that is because I don't know which one is the latest and greatest source code I've deployed. And we'll show you how the system will know it. But because each of those slots is given its own unique URL, that's going to change. And again, we want to get away from having to address that. And so we're going to manage that entry point into the main orchestrator through a queue. So let me pull up another screen. I'm going to exit out of here. And we'll stop that. Perfect. All right. So, come on. There we go. Get my notes open. So I mentioned we're going to have to touch a few things. Again, those familiar with Azure Functions in general, the host file is a common file that exists. And in here, we've got one key attribute that we need to address. We have the hub name, okay? This is what gets recorded inside of Azure when we are going after any number of things. So you see here, I'm looking out at an Azure instance right now. We've got a number of slots, and these slot where it says slot 0, slot 1, okay? These are actually the hub names, and they tie to tables. We got the history, the instances. You can actually open these guys up. You can see some past runs that I've performed on getting ready for this demo. So you've got the tables. Let's see, that went away. There it is. So we've got queues. So like I mentioned before, durable functions do a lot of their work through a queuing mechanism. And so they get a series of queues. And I don't think there's file shares. No, that's something different. So, and then we've got the blob container. So all of your payloads and stuff like that that come in inbound, and this is lease management, potentially could reside here. Large messages, if they exist, would reside inside of here. They won't store those inside tables if it's too big. So they create a link out to a blob container. So again, we'll make a change for managing it. We're going to get these things to live in their own slots. So we want to give them their own task hub name. You'll notice the percent signs on either side of this. That is basically a hook to their to the framework that basically tells it, hey, this is not the value I want you to use. I want you to go and look that up in your local settings file, or in our case, when it's deployed in Azure configuration. So you can see here that name here matches this. So that creates us a link that says when I'm running, I'm going to run as what, right? So that's going to change. And then we also have, we talked about queues, right? So from the change before, you saw me send it through an API. Well, that's great. How did that actually get there? That actually goes through a queue. So if we go and look at the orchestrator for, or I'm sorry, we want to look at the API. The API actually, and what we're going to do here is you'll see, right, is that we've got a queuing service. This is a class style that I use to kind of extract some of the noise away. But just know that all I'm doing is sending out to the expense report queue this payload. That payload winds up triggering this guy, which all it's doing is just passing it on to the orchestrator that I have chosen. Now, being mindful that when we look out here at our queues, right, all the slots have a whole bunch of working stuff, but I only have one queue, and that is going to get shared across all the slots, right? And so that's the other thing we talked about, is getting this insulated through queues instead of HTTP. Now, showed you the configuration values in here. We've got that. This is just a base URL to access the API, nothing special. One thing that you're not seeing here, and we'll go over into Azure to take a look at that. Now, for those that are CI/CD oriented, this is where the fun stuff comes in, because to remember to do this would be one thing, but to automate is another. So let's imagine if we had all 20 slots within a given environment. We've only got the two. We've only got the two. We got the production slot and slot 1. I could have up to 20 of these guys sitting here. I can't have all 20 of them running if they are all different versions of the code. Now, what we're doing here, right, is we're actually dictating which one is going to pick up based on this flag here. So this is no different than you going over here and then turning around and saying disabled, right? So across all my 20 slots, I only want to have one queue trigger enabled, and that one should be the latest running code. So that way I know that I've deployed my old code, the old code sitting in slot 0 or production. And what that's going to do is that it's going to do a whole bunch of work. I've got 30 days to get stuff done, but now I got a code change. It's breaking changes, changed to a signature. I deployed to slot 2, right? So what I'm going to do is turn around and just simply disable this. And just refresh this. And again, so both of them right now are disabled. So I want code to run in this slot, and I can change that quickly by the 0, or I could have gone over to functions and enabled it over there. So my entry point into these slots managed through the queues is dictated by these flags. And so what you also see here is they both share the same queue name, and that's actually using a similar style setup that we saw with Task Hub, right? Because I might want to do independent work potentially. Like I might have some other process that wants to put work out on this queue or another one, but just showing you that I can configure the name of a queue much like I can with the host name by using this special annotation that tells durable functions at large, durable functions specifically here, to reach out into the configuration and get that value that we want to use. Okay, so that is the key gist of this. Just to close the loop on the demo. All right, we'll go ahead and we'll clear the deck on this. All right, so right now, if I remember correctly, slot 1's doing the work, and I want to say put it right here actually. So if I did everything right, okay, and being mindful that I've already deployed this in advance, I didn't want to waste anyone's time here waiting for this stuff to bake. Okay, this here has been fired. Okay, and over there, we should see some traction there in a minute. And we're gonna go over to here, and we fired that off hopefully in the slot 1. And they're probably nice and cold. We see that message is actually sitting right there. So hopefully in just a short second, we will see that tick off. Sometimes queues are not immediate when they're cold. So that's been picked up by something. And maybe I'm not getting logging done. So let's go over here. Nope. So you'll see here, I'm actually attached to lot 1 on, and this is these individual pieces here are task hubs, right? So I'm attached to that, and you can see over here that that's running. So we know that that transitioned properly with the configuration change I made. And I have no problem right now changing this mid-stroke. And for those that are familiar with changing configuration values, that is a breaking change. Oh, that beat me to it. Flip off another one. And funny enough, I can hit this. This is fine because we're actually sending. I got 2 of these open now. There it is. So you see the 2 messages. So that's another nice part here using this style of implementation is that I'm technically not receiving any work, and that's okay. Enable that. So now slot 0 should be the one picking up. And unfortunately, configuration changes take a minute. There they are. Running. Only got so much time to shut this bad boy down. Well, I'm not going to be able to shut it down fast enough with a 30-second window, and that's just fine. But the point I'm making, and of course I'm asking for forgiveness and your blessing and understanding that I do have both of those pieces of code running out there independently. But what we've seen now is that we have isolated potentially this being the new code accepting new work, this one accepting old, switching these back and forth. So if it was under a normal circumstance, this would have lived here. I would have deployed out here. I would have had a number of these jobs just sitting out here in a yellow state waiting to finish. And then we would have deployed to here. But that work would have stayed here and would continue to run with that old code. So that way they would not end and they would go through there. Now, there may be business decisions to say, well, I want all the existing stuff to conform to that. That's a business rules. That's not for me to decide. But this has been a wild time getting this to work. And I think that this was a great story to bring to you guys and share with you. So wrapping up, just want to, again, we covered basics of what Azure functions are, just to kind of bring anyone up that's not familiar up to speed. We touched on durable functions. We walked through the basics of that, and we talked through the patterns, the gotchas, and the tools that you need. And then we also walked through a demo using the expense report as an example. We talked about mitigation options and versioning, slot deployment, and how that gets configured. And then we showed that out there and running in production in Azure as well. So at this point, love to turn it back over to you and see if there's any questions.
Chad, I don't see anything on the comment window, as well as I don't see anyone raising their hands. But since you wrapped up your presentation, I think it's a good time to call out. If anyone would like to ask anything, please feel free to unmute yourself. Sunil, I see you have raised your hand. Go ahead, unmute yourself, and you can ask your question to Chad.
Hey, Chad. This has been really nice presentation, covering from the basic to coming to your point. It was really good. I wanted to know, like, what are the complications did you face when you tried to implement this method of versioning, and what obstacles do you see here from maintenance perspective, reliability perspective, and anything that you can throw there?
No, that's an excellent question. That was one that we stressed and struggled over ourselves for quite a bit. One of the key gotchas, at least with this particular solution for versioning, right? This is really intended to solve those that we cannot escape by just resetting it, clearing the deck of whatever's out there, resubmitting the jobs and moving forward. They had to live out there. So looking at it though from a CI/CD pipeline perspective, okay, you only have 20 slots. So depending on your frequency of your deployments to production will also dictate, the combination of your frequency of deployments to production, as well as that time window that is allowable, right? So if you've got 30 days, you can't just drain the swamp and allow all those expense reports to drain out before you deploy. That's not acceptable. So you use the slot methodology to get it out there. But what if you are rolling out Azure functions once a day in your updates? You would potentially start walking through your 20 slots, and then you'd cycle back to the first one and you stomp on a bunch of work that's there. So that is one of the issues that we faced. And so we identified with the business what their time frame window was, that they were acceptable for them to actually die off, and then two, what the frequency was for their CI/CD pipelines for deployment. So, they seem to be working in 2-week iterations, and things are allowed to work for 2-week iterations. Well, if I deploy at 12 o'clock tonight, right, but I just received an expense report 2 minutes before deployment, right, that has another 2 weeks to live. So that was the considerations that we were taking into play here, is enabling us to probably at most need 2 or 3 slots. You know, on the off chance that we have to have a hot fix or something go out right away, we would do that. But we have the benefit of 20 slots that we can rotate through. In our CI/CD pipeline, we enabled it though to actually be a little bit more intelligent, and it could actually interrogate that durable function itself and ask it a question. There's a querying language, there's an API behind durable functions. In fact, the tool that operates this, there's a whole language in talking to that API, so you can run queries against it to understand, hey, do I have any jobs that are outstanding, that are pending, or what, that are still running? If not, I don't care. I'm going to deploy to that slot anyways. There's no work being done on it. So that highlights just some of the gotchas in that regard, and I hope that answers your question.
Yeah, thanks, Chad. I do have one more, Webo, unless.
Go ahead.
Oh, sure.
All right. The other question I had is, how does the hosting of Azure functions, like if you had different hosting mechanisms, like you're hosting in AKS versus the app service versus the serverless mode, does any of these impact this methodology? Like, does the hosting impact this methodology?
Sure. Excellent question again. I can't speak to AKS. My experience has been primarily with serverless as well as app service based. We found no differences in there. Again, if I try my best from a patterns and practices is to put everything into the serverless model. It's the cheapest, lowest cost way to operate any type of function, whether durable or not. Okay. And then if you have a significant scale and use case that you think you could benefit from, go to an app service. We did run into potential issues. I will put this caveat out there. It's a good point to make, is that we were running on a single app service instance, right, across multiple dev-like environments. Now, because we were testing with all 20 slots being consumed, keep in mind, if you provision through something like CI/CD and you provision all those slots to be in use, you are consuming and taking memory away from the rest of it. So in a serverless model, probably not an issue. But when you're dealing with a app service-based model, right, you're capping the amount of CPU and memory that you're going to allow all of these functions to share. And so problem that we ran into is that multiple environments were basically running 20 instances of the same application, well, not the same application, but 20 instances chewing up, even a few hundred megs of memory from all 20 of them across multiple environments. We found huge performance issues in that regard. So I would recommend always start your any Azure function development in the consumption based model before leaning on an app service model. I think you find yourself in a real good situation if you start there, and if you need something of more scale or more, because the one key benefit you get with app services is that you don't have a warm up time, right? So if there's time criticality involved, serverless, there is a penalty to cost for it to allocate resources to your instance to spin up, do its thing, and go down. Whereas with the app services side, you really, I don't think, pay that type of penalty.
Yeah, but the versioning method here we're using, in your opinion, won't change if you have different hosting.
No, nothing about this would change. I'm just raising awareness that if you're in the app services model versus the serverless model, right, you're putting yourself in a resource contention area on the app services. But we have not seen any issues or problems deploying it whatsoever. It's still, you're being given a number of slots and running I just would recommend starting off serverless just for cost reasons.
Thanks, Chad.
Yeah, you're welcome. Thank you.
Anyone else? If you have anything, feel free to unmute yourself and you can ask Chad anything that you would like to.
Yeah, I was hoping someone would give me a hard one.
No, it was a good topic. Chad, I really appreciate you taking time out for this. I think no one has anything else for it. So, and it's top of the hour. We can probably wrap up the meeting and a little early today, but wonderful session. I really enjoyed it. Hopefully everyone else who is on the call enjoyed it. Thank you once again for taking time out tonight and presenting. Same to our sponsor Trinity for sponsoring tonight's meeting.
Yeah, thank you. And if anyone has any questions about it, feel free to reach me on LinkedIn. I'm available.